Okay, welcome back. This is the last section, 8.7, Simplifying Expressions. Today we're going to talk about numerical coefficients, like terms, and combining like terms. Okay, first we're going to deal with this term called coefficient. Numerical coefficient, what is that? What's the number in front of the variable, or basically it's a number in front of the letter. So in this case, if you take a look at part A, 15n means, what is the numerical coefficient of that? Well, it's 15. In part B, what is the numerical coefficient in front of the m? And that is the 20, but it's also negative, so it's negative 20. Okay, like terms, I'm going to try to give you all the list of 4 different ways of looking at like terms. Like terms means, and I'm going to demonstrate this in part A, it means you have the same variable. It does not matter about the numerical coefficient or what that number in front of it is. It does not matter about the blue. All I care about is what I underline. So in essence, can we add and subtract these? Absolutely. Because it's got a lowercase m. So I'm going to say yes. Now in part B, even though you've got n, you've got an exponent attached, but you do not have one here. That's the same. So this means this would have to be a 2 for this to be like terms. So this is a no. What about 6t? And well, I've got t's, so usually what I get a lot of my students in the past would say yes because it's t. Well, take a look at that. Are those t's? They're the same letter, but one's lowercase and one's uppercase. And that matters. It has to be the same lowercase or uppercase, so this is a no. Now finally, this is kind of a trick one too. Now remember, we don't care about the number that I'm circling. All we're caring about is what I'm underlining. M and N. Well, this has got an M and an N. Even though it's not in the right order, we still say that this is, because really, this is the same as saying 1/4 M N. Okay, combining like terms. Now, one thing I like to teach is when I was taught going through grade school is we would make marks of like terms. So I'm going to underline when I see an N, and then the number I'm going to underline twice. So what I'm doing is I'm taking 2n minus 9n, and I'm also taking -4 and a -8. So 2 minus 9 is a -7n, and then I've got a -4, -8. If you owe me 4 and owe me 8, you owe me 12, so that's going to be -12. And at this point, if you all want to pause to see if you can do these on your own, feel free to. Next, I got a 6m, a -6m. Then I've got a -5 and a -8. Now, these right here cancel each other out, so you do not need to put anything here. The common thing would be we would do an m because we say, well, 6 minus 6 is 0, but that's not what that means. That would be a 0m, which actually would disappear. So now I'm concerned with this. -5 and a -8 would give me a total of a -13. Part C, I've got quite a few x's, 2, -5, 4, and 3. And then I've just got my lone -8. So right off the bat, I know that I've got my -8, so I'm going to treat that as a -8. Now I'm going to take my 2x, my plus 4x, my plus 3x, and then my -5x. I'm going to put that negative on the bottom. So 2 plus 4 plus 3, that would give me 9x minus 5x, which would give me a total of 4x. So it's 4x minus 8. Part D, you're going to have to distribute the 5 to the parentheses, so that would turn into 5x. 5 times negative 3 is negative 15. I still have that plus 4. So that's 5x. So negative 15 plus 4 would give me a negative 11. So that would be minus 11. Okay, part E, I've got two things I'm going to distribute. I'm going to say, okay, 2 times 3x is 6x. 2 times negative 4 is negative 8. Negative 4 times x is negative 4x. And negative 4 times negative 2 is a positive x, or positive 8. Next, combine them. So 6x minus 4x. Negative 8 plus 8. That gives me 2x. These cancel, would form 0, so I don't need anything. The 2x is my answer. Now, F. Common mistake. We say 2 plus 3 is 5, then distribute. This is not how you do it. What we do is you take your 2 and then you distribute the 3. So 3 times 7n is 21n. 3 times negative 7 is a negative 21. So I've got, those are my like terms. So 21n, negative 21 plus 2 gives me a minus 19. Finally, our favorite kind of problem with a fraction. So right off the bat, I'm saying, okay, 1/4, I'm going to distribute it. So how many times does 4 go into 24? 6 times. So at 6 is also, you've got that m. Then how many times does 4 go into, so I'm going to distribute this to the 16, so that's going to be a negative. 4 goes into 16 4 times. I'm going to treat this as a negative 1. Negative 1 times m is negative m. Negative 1 times 6 is negative 6. Combining like terms. So I got 6m minus m, a negative 4 and a negative 6. This would be 6m minus m is 5m. You owe me 4 and owe me 6, you owe me 10, so it's minus 10. That's my answer. Now finally you could be asked like kind of like a word problem. So let's read this for a second. Triple a number. Okay, now triple a number minus the sum of a number in 3. Use x as the number. Well, x is a number, so let's think about this for a second before we do my two-part question of this. What does triple a number mean? Well, it's 3 in a number, which we're using x. I'm going to say 3x minus the sum of a number in 3. So I know a number is x plus 3. So I know this is what they're asking me. So I'm going to take this, what the 3x minus x, and then parentheses x plus 3. And that's what we call our algebraic expression. It's that the triple a number minus the sum of a number plus 3. In part B, so this is part A. So in part B, we're taking this 3x, I'm going to rewrite it, 3x minus x plus 3, and we're going to make that a negative 1. And what I'm going to do is I'm going to distribute that negative 1. So it's going to be 3x minus x, and then negative 1 times 3 is negative 3. So 3x minus x is 2x minus 3. This is what solving would mean. Okay, thank you for listening. And I will see you in my Math 61 class when we're dealing with Unit 9. Thank you very much.